A very good morning, dear students. Welcome to the world of chemistry. And but this is digital classes and chemistry period. Today we are going to start our topic bond parameters and polarity from Unit 4 Chemical Bonding and Molecular Structure. So before going to start, dear students, let's start with the positive mindset. It is the thought that I'm going to dedicate today one of my champ, one of my student who has brought laurel and accolades result for the school, and she is Miss Leila Khan, our star performer who got 5th position in HP board matriculation merit. Congratulations to Leila Khan. She scored 687 score out of 700, in which she scored 100 upon 100 in science, 100 upon 100 in SST. So congratulations to Leila Khan, and congratulate to all the students, all the 51 students of DAV Public School Manali who has brought tremendously excellent result for the school, outstanding result for the school with 100%. So thanks a lot to everyone, and we on the behalf of whole DAV family, I would like to congratulate you all. Okay, so Leila Khan, this is for you. The harder you work, this is the message from Leila Khan to everyone. The harder you work for something, the greater you will feel when you achieve it. Yes, it's true. It is yesterday when I was taking Leila Khan's interview. So it was she was telling like this way she has done to get this position. She has done lots of hard work, lots of work, and most important, she was very much fair and loyal with the instruction that is time to time that her teacher is giving, that instruction which we were giving, the guidance that we were giving. So please, dear student, take this message from her and inculcate and try to follow this in your life also. Your teachers, they always going to guide you, they always telling you about the things that is going to be give in future benefit to you. So it is her hard work that today she achieved a very great result, a great success. So once again, on the behalf of whole DAV family, on the behalf of our worthy principal Leila Khan, you are our star performer. Congratulations to you. Hope so same type of result you will repeat in your plus 2 class. Thank you. So let's start unit 4. We are doing total 4 marks it will come, and we will start with the what is chemical bond. As dear student, we know the attractive forces which hold various constituents such as atom, molecules, ion together in different chemical species, it is called covalent bond. These are called covalent bond. It is the attractive force. It is the attractive force or the force that constituent atom, ion, or any other particles with each other. That is called covalent bond. A covalent bond includes the sharing of electron between two atoms, or by donating and accepting the electron between two electrons. Okay, so let's understand chemical bond with the help of this theory, this page. So you can see here, dear student, before going to that, I think you have seen H2, O2, Cl2, so many element in molecular form. Like H is hydrogen element, but H2 is hydrogen gas which is present in our surrounding. O is oxygen element, but O2 is oxygen gas in our surrounding. Okay, so how these O2 is forming? So there is one hydrogen and other hydrogen. One hydrogen have one electron, other hydrogen have one electron. But to make a molecule, these two individual hydrogen must share electron and form H2. So it means H and H will react, H and H will react to form H2. Okay, so this is called the force that is binding this H2, that is called hydrogen that is called chemical bond. Okay, it is according to Lewis theory. There are electron dot, we are making the electron dot, mean the electron present in outermost shell, that those electron are going to participate to make the form bond. Suppose one try to understand with this conversation of two atom, like sodium atom is asking to chlorine atom, I have an extra one atom electron here, can you take it? So chlorine is saying I only have 17 electron. Yes, chlorine electron atomic number is 17, so it has electron 7. So wherever you want to find how many outermost electron is there, so very simple. If we will take sodium, so it is 2, 8 and 1. Whereas in chlorine we will take, the chlorine is 2, it is 17, so 287. So you can see here, in case of sodium, there are 281, 1 electron in outermost shell, whereas in case of chlorine, there are 7 electrons in outermost shell. So in this case position, both the element doesn't have 8 electron in outermost shell. But what they can do, hydrogen can give 1 electron and becoming 8 in outermost, whereas chlorine can take electron and become 8 in outermost. Okay, this type of chemistry, this type of sharing is called chemical bond. Okay, so sodium will give 1 electron to chlorine and chlorine is happy. Wow, are you sure you are giving 1 electron to me? And sodium is saying yes, then I am giving 1 electron to you. After giving 1 electron, I am becoming positive and you are becoming negative. It is not the mathematical sign of positive negative. Let me tell you, positive mean proton and negative mean electron. It means that, as we know, proton and electron should be equal in atom. But when sodium will give 1 electron, it means that it has 1 extra proton in nucleus. That's why 1 positive charge. Whereas in chlorine, it will take 1 extra electron, but number of proton is 17. But number of electron become 18 now. So because of that, 1 extra electron is there. Hope so you understood this. After this, once the two element combine, two atom joined with the help of any chemical bond, then it is forming molecule. Okay, so basically atoms joined together by covalent bond form molecule, as the chapter name is chemical bonding and molecular structure. So after forming the chemical bond, the atom is combining and atom convert into molecule. So molecule is the smallest unit of most compound. Molecule is the smallest unit of most of the compound. After molecule, compound is formed. All compound are molecule, but not all molecule are compound. This is very important. All compound are molecule, but not all molecule are compound. So like here conversation is there. Sarah, I am cold, and Emily is saying I am also cold. So Emily and Sarah store the blanket, share the blanket, sorry, and both of they will not feel now cozy and comfortable after sharing the blanket. So it means that similar way, single atom, it is not stable when they are single. So single atom is not stable, but when they will combine with chemical bond, then they are becoming stable. Okay, so because of this reason, elements are combining with each other. So here one example again, it is same example. Suppose sodium, chlorine is saying sodium is having 1 extra electron, so sodium is sharing with chlorine, and chlorine and both they have one relation now, and happily they are staying as a molecule, sodium chloride. Okay, so dear students, we have already done these things in previous video also, why there is need to combine element. So Cossel-Lewis approach is saying that according to Cossel-Lewis, the elements are combined to become satisfy and to become stable. How they can become stable? By getting 8 electron in outermost shell except hydrogen, lithium, beryllium. Hydrogen, lithium, beryllium is not becoming octet, they are becoming duplet by becoming 2 electron in outermost shell, but rest all element in the periodic table become they need to be become 8, they need to be become like a noble gas, then only they are stable in the nature. Okay, so there is a big mystery in the nature, why there we are getting new and new things daily. Reason? Because those old elements which are not stable in nature, these old elements are keep on trying to react with each other and forming a stable. They will keep on reacting until they will not form a stable molecule. Okay, for that purpose they are combining. So basic theory of Cossel is this. We know that in the periodic table, the highly electronegative, which is halogen 17 group, and highly electropositive, which is alkali metal first group. So you know first and 17, there is between first and 17 one separate group, that is 18 group, which is called noble gas. So when first group, this is metal, 1 electron is extra, when they are sharing 1 electron to non-metal, and non-metal is, that is halogen, which is taking 1 electron, they are becoming somehow that noble gases, configuration like noble gas. Okay, the formation of negative ion from halogen atom and the positive ion from alkali metal associated with the gain and loss of electron and by the respective atom. The negative and positive ions thus formed attain stable noble gas electronic configuration. The noble gas electronic configuration, which is in hydrogen, helium, lithium duplet, and rest other elements octet. That is configuration that is making the element stable. Because of that, it is. How then we are representing that sharing of electron or donation or acceptance of electron? For that purpose, we should make the dot structure that you did in 10th class also. Dot structures. Well, lithium have 3. If lithium have 3 electron, so mean how to draw the 3 electron? It is 2 in K and 1 in L. Now this 1 in L, this is going to represent here as a dot. Okay, in every element when we will write electronic configuration, it is very simple method to draw dot structure. You have to write atomic number, then divide. Suppose I will take example of beryllium. So atomic number of beryllium is 4, as you know. Now these 4 we will distribute according to Bohr's magic number, 2, 8, 8, 18, 18. Okay, so distribute this 4 in the form of shell. So this 2 is in K shell and this 2 is in L shell. Okay, now this K shell is filled, so we will write only those electron in dot. We will draw those electron in dot which is in outermost shell. So this, because of that, this 2 is drawn here in beryllium. Like this way, boron, carbon, nitrogen, you can fill. Okay, and this dot, which is dot, this dot is giving us this hint ki how many electron this particular element is going to share. Suppose lithium will share only 1 electron, but beryllium has to share 2, boron has to share 3. So like this way, how the number of electrons share, number of bond they will form. Suppose lithium can form 1 bond, now beryllium can form 2 bond, boron 3 bond, carbon 4 bond, like this way. And number of bond mean number of strength. Okay, so electron dot structure. Now octet rule, the octet rule is what? Basically it is according to octet rule, the configuration, atom can combine either by transfer of valence electron from one atom to other atom, or by sharing the valence electron in order to have their octet in the valence shell. And the moment atom is electron sharing 1 electron, suppose if I will take example of this first one, so 2 hydrogen atom is there. You can see here 1 electron is shared by this hydrogen to other, and the other electron become duplet. Okay, so this type of reaction is called, if we will take like this way, by donating one element is donating 1 electron, other is accepting, this type of bond is called ionic bond. This type of bond is called ionic bond. Whereas on the other hand side, you can see here, if I will take 2 fluorine example, the fluorine have 9 electron, in which 2 and 7 is the configuration. The 7 electron need to be drawn in outermost shell, so you can see 7 electron has drawn. So 7 mean all 3 side pair, 2, 4, 6, but this side only 7, but we need 8 electrons. So what we need to do, we need to, this fluorine also want 8 electron, this fluorine also want 8 electron. So these 2 fluorine will do what? This fluorine will share this electron with this fluorine, and second fluorine will share 1 electron with first fluorine. In this way, these 2 fluorine is easily combined with the help of this sharing of electron. So this type of molecule in which 2 electron is shared and form in stable molecule, form octet. This is, you can see 8 electron and you can see 8 electron. Okay, so this is common, these 2 electron are common. So this type of bond is called covalent bond. Okay, so how to make the molecule? This is to just 2 type of element. This is mono, I can say it is homo molecule. Yeah, I can say the same type of molecule, like H2 is same type, F2 is same type, but this is hetero, more than 2 type of elements, CO2, one is C, second is oxygen. Okay, this is also forming ionic bond, basically because these are sharing, or covalent bond also can be. It depends how. If oxygen is donating electron to, if carbon is donating electron to oxygen, then it is ionic. If oxygen is sharing electron with carbon, then it is covalent. Okay, so this is the basic difference between ionic and covalent. So there are 2 type of chemical bond, ionic bond and covalent bond. Ionic bond is same, in which one is donating electron to other, and other is accepting electron, and that who is donating, that is carrying positive charge, and who is accepting that, on that it is negative charge. Basically this type of bond is occurring between metal and non-metal. Okay, whereas covalent bond, I can't get an electron from you, neither I can give you. When this kind of situation is there, the atom cannot get any electron from anyone, or neither it can give any electron, but they can share electron with each other. Okay, the sharing, mutual sharing of electron is known as covalent bond. So these are the 2 different type of bond. Both type of bond is used in many of the molecules, but most important that we will study, that is covalent bond in this chapter. So covalent bond is given by Langmuir. He refined that Lewis postulate by introducing the covalent bond. According to his, covalent bond is formed by sharing of electron between 2 shell or subshell. This is the example, and this is one example also. Like you can see, hydrogen need to become duplet and carbon need to become octet. So how they can become? Carbon have only red color electron is of carbon, blue color is the electron of, I'm talking about this blue color electron is of hydrogen. So you can see the red color is of hydrogen and blue color is of carbon. It is given here in the bottom. So if red color electron hydrogen will share one electron with carbon blue color, so it will form his duplet. Okay, so hydrogen is getting its duplet pair, whereas carbon is getting its octet pair. You can see 8 electron is there now. Okay, so this type of example is of covalent bond. So basically when we studied about chemical bond, it is its definition and its types, what is chemical bond, why there need to chemical need to bond, how we can transfer the electron from one atom to another. Then we need to talk about the characteristics of covalent bond. Basically the covalent bond is characterized by bond parameter. Okay, so what are the basic characteristics of covalent bond? First characteristics of covalent bond is, here only definitions are there, so please dear student learn definitions. Okay, this is the basically bond length. First characteristic is bond length. Bond length is defined as the equilibrium distance between the nuclei of two bond. Now when think practical, when two atom will combine with the help of one bond, when two atom will combine with the help of two bond, like one atom is this, second atom is this, when one atom atomic radii is this, second atom atomic radii is this, so this is becoming the bond length. So more the bigger atom, more will be bigger bond length. Okay, so bond length is measured by spectroscopy basically, or X-ray diffraction technology. Each atom of the bond pair contribute to the bond length. Okay, suppose three atom is combining, so it means that this is bond length A, this is bond length B, and this is bond length C. Okay, it is like mathematically bond length is the distance between the nucleus of two bonded atom in a molecule. So bond length decide the size of molecule. Second, in case of covalent bond, the contribution from each atom is called covalent radius, and the covalent radius is measured approximately as the radius of an atom core which is in contact with the core of an adjacent atom to the bonded situation. Van der Waals force radius represent overall size of the atom, which includes its valence shell and non-bonded situation. Second is, which thing is deciding, if bond length is deciding the size, which thing is deciding the shape of molecule? That is bond angle. Okay, bond angle is what now? It is simply, if suppose three electron element are bonded, atom is bonded with the help of bond length, so that this distance between two radius, I can say, is known as bond angle. You know in mathematics also what is bond angle. Bond angle show the shape. If suppose bond angle is simple 180, then it is linear shape. If bond angle is suppose like this way, then it is showing trigonal. If bond angle is like this way, then it is tetrahedral. If bond angle is suppose this way, then it is trigonal bipyramidal. Okay, so all these shape in future we are going to study. That is the contribution of bond angle. So it is defined as the angle between the orbital containing binding electron pair around the central atom in a molecule or complex sign. Bond angle is expressed in degree also. Okay, like 60 degree, 90 degree, 120 degree. So whenever we are going to talk about structure, as you studied last year, the structure of diamond. This is structure of diamond, 3-dimensional. So you know 90 degree is the bond angle. Because of 90 degree, the fixed symmetry is there. Okay, so second parameter is bond angle. Third parameter is bond enthalpy. Now if size is told by bond length, if shape is expressed by bond angle, now the strength is expressed by bond enthalpy. It is defined as the amount of energy required to break 1 mole of bond in a particular type between two atoms in a gas state. The unit of bond enthalpy is in kilojoule, and suppose to make hydrogen bond, there we required 435.8 kilojoule per mole. So to break this H2 bond, we need this much energy. To break this O2 bond, we need this much energy. Okay, so more the bond order matlab one single bond, double bond, triple bond, more will be the energy. Okay, the larger in bond resistance and the stronger will the bond in molecule. In case of polyatomic molecule, the measurement of bond strength in the following way. We suppose H2 is a polyatomic. First we need to break down H2 into H plus OH. Then we need to break down OH into H plus O. So if H2O is break down into H plus OH, this is taking this much energy. If OH is breaking down into H plus O, then it will take this much energy. When we will take the average bond enthalpy, this plus this, you can see here, this plus this upon 2, it is very simple mathematics. So this much energy required. There is nothing to use any rocket science here, very simple average mathematics. And fourth bond parameter is bond order. This bond order is giving us idea about number of bond between the element. So single bond, double bond, triple bond. You know alkane, alkyne. We did in 9th class also. 10th class also. In Lewis description, the covalent bond of the bond order is given in the number of bond also. For example, the H2 is combined with single shared pair of electron, that is single bond. The O2 combined with the 2 shared pair of electron, that is double bond, and N2 combined with the 3 shared of pair of electron, that is triple bond. Let me take example. H have one single electron, so they will, when they will combine, they will combine with single pair of electron, that's why it is single bond. O have 1 2, 6 electron are there in one single oxygen, so when it will react with other 1 2 6 electron, so 6, it has 6, but when 2 electron is going to be combined, so it will form like this way, for making bond 2 pair of electrons, so that double bond. In the same way, N2 is triple bond. Okay, so single bond is known as alkane in carbon compound, double bond is known as alkene, and triple bond known as alkyne. Okay, so you know very well about this. So the resonance, somewhere resonance structure is the characteristics of covalent. So same formula but different position of bond is called resonance. So a single Lewis structure may be adequate for representing a molecule. According to the concept of resonance, whenever a single Lewis structure cannot describe, whenever single Lewis structure, जब भी एक सिंगल स्ट्रक्चर पॉसिबल नहीं करता है मॉलिक्यूल को डिस्क्राइब करने के लिए, तो हमें उसके स्ट्रक्चर को चेंज करना पड़ता है, उसके बॉन्ड को चेंज करना पड़ता है. दैट कंडीशन वेयर बॉन्ड वी आर चेंजिंग, दैट इज कॉल्ड रेजोनेंस स्ट्रक्चर. नंबर ऑफ स्ट्रक्चर विद सिमिलर एनर्जी. The meaning of resonance is number of structure with similar energy. Like sometime we are changing your position to understand your proper character property. So that is called resonance. Position of nuclei, binding and non-bonding pair. Bonding and non-bonding pair of electron are taken as canonical structure of the hybrid. One example we will take here of ozone. For example, O3. This is the one shape of O3. You can see a double bond is between 1, 2, 3, between 1 and 2 atom now, but in the other case 1, 2, the double bond is between now 2 and 3. So that kind of condition where formula is not going to change, formula is same, but structure is going to change, that is called, because of the change in bond, that type of structure is called resonance structure. For O3, these two structure constitute a canonical structure. These two structure is for ozone canonical structure, in which is called resonance structure also, and it show the hybrid structure. Hybrid means mix, बीच में, इन दोनों के बीच का स्ट्रक्चर ये है, ठीक है. वेयर पार्शली द बॉन्ड, पार्शियल स्ट्रेंथ ऑफ द बॉन्ड is between 1, 2 and 2 and 3 also. Okay, so in general it may state that resonance stabilization of molecule as the energy of resonance hybrid is less than the energy of any single canonical structure. It means that the energy of resonance is less than the energy of any single resonance structure. Resonance average of the bond characteristic as a whole. What is resonance energy? Now it is the difference between the actual bond energy of molecule and that of the most stable of the resonating structure which have least energy. Okay, so dear student, we have done all the characteristics of covalent bond. Now we will study about how covalent bond, what covalent bond. Covalent bond can be directional, mean covalent bond can be directional, mean one in any direction covalent can be formed, so that is called polarity. Basically polarity of bond is, it is the existence of 100% ionic or covalent bond representation. How we can come to know this molecule is going to be form ionic bond, this molecule is going to be form covalent bond. To get that, to know that, to know about that information, which type of bond is going to be ionic or covalent, for that we should have knowledge of covalent bond. When a covalent bond is formed between two similar atoms, for example H2, O2, Cl2, N2, F2, the shared pair of electron is equally attracted by two atoms. As a result, electron pair is situated exactly between the two identical nuclei. The bond so formed is called non-polar covalent bond. And contrary, in case of hetero nuclear molecule, basically homonuclear molecule is called form non-polarity bond, whereas hetero molecular nuclei, for example HF, HCl, these are forming basically polar electron bond. Okay, we can calculate this with the help of dipole moment. It is very important definition. As a result of polarization, the molecule possesses the dipole moment. What is dipole moment now? It is defined as the product of magnitude of charges and the distance between the center of positive and negative charge. It is the product of magnitude of the charges and the distance between, from here it is definition, and the distance between the center of positive and negative charge. Okay, it is usually designated by mu in Greek word, which is mathematically expressed like this way. Dipole moment is mu is equal to charge is q, so mu is equal to q into r. This is the dipole moment formula. Mu is equal to q into r, where one dipole is one dipole is 3.3356 into 10 raised power minus 30 centimeter. One dipole is equal to this much, okay, where C is coulomb and M is meter. So this is very important page. Pause it and read this full, okay, try to understand. So two type of polarity are heteronuclear, which is heteronuclear, that is polar mean now chlorine and hydrogen is reacting. You can see this picture. Chlorine is taking forcefully the electron from hydrogen. Chlorine is taking forcefully the electron from hydrogen. It means that the electron position movement of hydrogen is toward this side, chlorine की तरफ को है. So that is called polar. Polar मतलब directional. Whereas non-polar covalent bond is there. As tug of war game you are playing, and one team which is strong, if it is pulling whole team, that is called polar. Whereas when tug of war both team is equal in strength, then they can not pull the electron of each other, whether they are forcing to each other. This is forcing this side and this is forcing this side, so there is no pole. Polarity is becoming zero, so that's why it is called non-polar. Hope so you understood with the help of this diagram. So this is all about for today, and conclusion is, we did what is chemical bond. This is force that hold two atom together. We did what is an atom ionic bond. It is electrostatic force which hold a positively charged particle together in ionic compound, and how it form and when it form, what are atom and compound always trying to achieve, that is stability, why atoms are combining to achieve stability and to complete the set of valence electron. Okay, this we studied. Hope so you enjoyed this video, dear students. Thanks for watching this video, and till my next video, stay home, stay safe, have a nice day. Once again, congratulate to all the students, those who clear their matriculation result. And yes, definitely now you have adopted science +1, so your target should be next now. Try to get more good marks in +2 class.